In 1912, Sir Arthur Conan Doyle wrote this famous book, The Lost World, an adventure into the past, filled with prehistoric monsters, a place that time forgot. Hi, I'm George Page for Nature. The Lost World took readers to the mysterious, unexplored tepuis, plateau-topped mountains in southern Venezuela. Towering thousands of feet above the jungle floor, they stand separate from the world below, isolated and inaccessible. This week, we follow filmmaker Wolfgang Bayer as he travels to Venezuela to bring back their real story. Millions of years of isolation have made the tepuis mountaintop laboratories of evolution. And while we no longer expect to find dinosaurs, each tepui expedition has discovered new forms of life. Imagine that. We're still discovering new forms of life this late in the 20th century. The tepuis represent a landlocked Galapagos, which we're just beginning to understand. Deep in southeastern Venezuela, in a region called the Gran Sabana, strange mountains rise from the jungle. Giant columns of sandstone jutting abruptly skyward from an emerald sea of rainforest. Shrouded in mists, their summits are special worlds, mysteries of evolution, biological treasure islands distinct from the jungle below. This landscape is one of the oldest on Earth. Long before the age of dinosaurs, before the continents split and the Atlantic Ocean was born, even before the first terrestrial life emerged from the sea, a massive sandstone plateau reached across this land for 1,000 miles. These mountains are all that remain. Indian legends say that some are the ancient stumps of the trees of life, cut down in a harvest of greed for their fruit. They're known by their Indian name, tepuis. It's been just over 100 years since the first European naturalist stood here on the vast summit of Mount Roraima, one of the largest tepuis. The craggy surface has weathered into fantastic shapes. Cold winds and fogs play across its harsh expanse, replacing tropical sunlight with a chilly gloom. And in its eroded rock faces are the portraits of time. This is the lost world Sir Arthur Conan Doyle populated with dinosaurs in his famous story. It's not so far from the truth. Strange and contradictory life forms found nowhere else flourish on these remote plateaus. Many are completely new to science and have yet to be identified. There are more than 50 tepuis in Venezuela. Most of them ascend from the plain of the Gran Sabana, a vast carpet of rainforest dotted with grassland. The tremendous power of water has carved and separated the plateaus, relentlessly working at the rock for hundreds of millions of years. Cutting vertical walls in the sandstone layers, the water exposes the past, opening up a record of 1.5 billion years. Eons of erosion have created an archipelago of distinct habitats, laboratories of evolution, where plants and animals have developed in response to a world much older than that of the grand savanna below. These sedimentary sandstones are too ancient to contain fossils. Nevertheless, history is written in their layers. And as erosion exposes the past, some surprises come to light. Beautiful crystals like these of pure quartz gave rise to tales of fabulous jewels atop the tepuis, tales as yet unrealized. But the wealth of water pouring from the tepuis has created breathtaking beauty. Angel Falls, descending 3,212 feet, the world's highest waterfall, surging from near the top of Ayan Tepui. Reports of such great wonders brought explorers and adventurers into this remote region. The spectacular cataracts of the tepuis were photographed from the air by early pilots. But the first extensive exploration was begun by Captain Felix Cardona Puig in 1927. Captain Cardona, initially an explorer, cataloged large numbers of previously undiscovered plants. Pilot Jimmy Angel, pursuing stories of gold, attempted unsuccessfully to land his plane on Ayan Tepui in 1937. He found no gold, but discovered the great waterfall which now bears his name. The Phelps expeditions, begun in 1938, set out to explore many of the more remote tepuis. William and Kathy Phelps continued to work in the region until the 1960s, and the highest tepui, Pico Phelps, is named for them. Today, new explorers have taken up their work. The tepuis are magnets for scientists studying the mysteries of evolution. Their sheer sides divide them into distinct biological realms. Each one is different. Each one offers new species to discover, new clues to the development of life itself. These explorers come with the questions of modern science, seeking new knowledge from these islands in time. The tepui formations are anchored in the stable granite bedrock of the Guiana Shield, the massive continental core of South America. Only a few degrees north of the equator, they have never been glaciated, never inundated by the rise and fall of prehistoric seas, never torn apart by the upheavals of mountain building. They stand as a faithful record of a distant past long vanished from most of the earth. They are among the few places where terrestrial life may have existed without interruption since it began, some 400 million years ago. This multinational team of scientists is conducting cooperative studies of tepui ecosystems. By combining their individual research specialties, they're seeking to understand each tepui and how together the tepuis influence the environment of the region. The climate here is dramatically different from the tropical forest below. Perpetual cloud cover brings mist and rain and temperatures that drop to just above freezing. Vegetation has developed in response to these conditions. Lichens, more at home in the Arctic, cling to the bare rock. An opportunistic member of the blueberry family hangs in precarious determination. Here on Roraima, little soil has developed. Located on the eastern edge of the Guayana Shield, it's constantly buffeted by the strong easterly trade winds. And it's not only plants that have to cope with the high winds. The tiny Roraima toad, found only here, has developed an unusual method of locomotion. Curling into a ball, it rolls over the rock. An awkward walk is only preparation for a daredevil leap. A crevasse sheltered from the wind is a garden spot compared to the forbidding surface above. The many species endemic to the tepuis are still being discovered. Some are early forms of modern species, stranded on these plateaus as the tepuis became progressively isolated. A quiet pond is home to an unidentified cricket. Conan Doyle may have exaggerated the size of the reptiles, but he was right in speculating that evolution had left behind some ancient relics of a younger planet. The rugged terrain provides an enormous variety of habitats, and each one remains a different and surprising world. The scientists plan their fieldwork, mapping out a coordinated effort to maximize the effectiveness of their research.
Que ella dando la vuelta por aquí, que se extiende en el radar se ve la parte ahí, en esa parte.
Dr. Carlos Schubert is the paleoecologist. Dr. Otto Huber, the botanist.
¿Dónde dijiste que viste el contacto de diarasa con arenisca?
Eso es aquí aproximadamente. Que ella dando la vuelta por aquí, que se extiende en el radar se ve.
Dr. Stefan Garzula and Dr. Henry Briceño are the zoologist and the geologist of the expedition. They begin their research with the rocks themselves. Dr. Briceño studies the forces that created the tepuis, erosion and uplifting, as part of a new dynamic theory of the history of the Guayana Shield.
is a good example of how water has been working its way down cracks along the border of the tepuis, eroding away the rock and opening this wider and taking all these sediments down to the Caroni Basin. So we have the forces, tectonics, pushing up, and erosion, eroding away the sediments and trying to erode the whole thing and make this flat. So we have that balance between those two forces, one tectonics and the other one erosion.
As a paleoecologist, Dr. Schubert studies the history of these habitats and how a community of plants becomes established.
Algae are the first substrate, organic substrate, that forms in the little puddles on top of the rock. As soon as this substrate forms, then the lichens and other plants come in and they begin to grow there and begin to add to this substrate until eventually larger plants can come in and grow in this place and actually form a community. In time, they will get larger and larger. The process will accelerate because of the larger organic deposition, and they will eventually coalesce and form the forest that we see covering the tepuis to a large extent.
Schubert and his assistant take samples of peat moss. They look for the deepest deposits and use radiocarbon dating to determine the age of the sample. The earliest deposits found are only 8,000 years old, roughly coinciding with the end of the last ice age. Schubert hypothesizes that during the ice ages, the tepuis became so cold and dry that soil-forming processes stopped. Plants migrated to lower elevations and then back again as the climate changed. While many of these species are ancient, their communities actually may be surprisingly young. Dr. Otto Huber studies the distribution of the unique vegetation.
The tepuis in Guyana are characterized that each of them has a different vegetation and different flora. And long time this has believed to be due to the fact that all of the tepuis were so isolated from each other and from the surrounding lowlands.
But Huber is discovering that the tepui's isolation is not so complete as was once thought. Although many species are endemic, the tepuis also share many species in common. They even show similarity to vegetation in the Andes and as far away as Mount Kilimanjaro in Africa. The key to life on the tepuis is not just their isolation, but also their climate and altitude.
I think we have started to demonstrate in the last years with our research that this static view, this view of things that would never change in time is probably wrong. Enormous number of different ecosystems and the long time at their disposal to evolve in each single niche have offered, even to a young and dynamic flora, to speciate, to open up like a fan in millions of different life forms and adaptations.
These environments offer few nutrients, and some plants have found animal protein an excellent source of vital nitrogen. This sundew, endemic to the region, uses sticky glands to trap an insect, which will later be digested and absorbed. The beautiful blossom of the sun pitcher. Unwary insects are attracted to the nectaries in the cupped leaves. But this genus, found only in the tepuis, is too primitive to excrete digestive enzymes. It relies on bacteria to break down its prey. Mosquito larvae, however, thrive in the tiny, nutrient-rich pools. They will hatch to fly out of this insect trap. Dr. Stefan Gorzula, zoologist.
We've spent 5 years exploring around about 40 tepuis in southeastern Venezuela. We've lived months up on the tepuis over this period. We've now got a very good impression of what the tepui fauna is composed of, which is basically small rodents, the occasional opportunistic species like opossums, coatimundis, small reptiles such as lizards, snakes, and amphibians. These are ecosystems which have very low fertility. The growth rate of the plants, everything is in a very, very slow turnover and just doesn't give nutrients that would support large mammals like deer, peccaries, large predators.
Each expedition offers the chance to find an animal no one else has ever seen.
Tubular bromeliads are quite often very abundant on tepuis, and each one of them has a nice little microhabitat with a water reserve in the base which frogs can hide in. So one of the sampling methods that one uses on tepuis is to walk along looking into bromeliad tubes. And if there are any frogs inside, one can see them immediately before they drop down into and try and hide themselves in the water.
Gorzula has discovered more than 25 new vertebrate species, including this little frog, named Stephania in his honor.
Most species have got breeding strategies where they lay a very few large eggs with enough yolks so that the frog can develop completely within the egg without having a free-living tadpole stage. Stephania carries the eggs for the whole period of their development on her back.
Collecting animals isn't always so easy. Some creatures make it a contest. And there's always one that gets away. Compiling a complete zoological record on the rugged surface of the tepui entails exploring all its hiding places. The many caves may be explored at night. Daytime offers no advantage here. The sound of the water rushing through these caves often makes too much noise to hear a creature move. Gorzula watches for the reflections of his spotlight in a pair of eyes. When he finds a specimen, the light blinds it long enough for him to grab it. Most creatures that make their home on a tepui are small and difficult to spot, but some actually seek out the scientists.
We've made a very interesting discovery. This is an endemic subspecies of opossum, and the best way to sample them is to hang up 3-day-old salami and wait for them to come into camp. This species occurs from Chile in the lowlands, Argentina in the lowlands. As you go further north, they're found at very high altitudes up into the Andes of Venezuela. And there's also this endemic subspecies in the tepuis. See the rather beautiful face, beautiful markings compared to the ordinary lowland opossum. Well, there you go. And tell your friends about the good salami.
Great torrents of water link the tepuis to the lowlands. The rainy season lasts most of the year, producing a seemingly inexhaustible supply of water. Bit by bit, water is carrying the tepuis away, depositing their sediments downstream. In this region, the streams drain into the Rio Caroni, a major tributary of the Orinoco. The tremendous volume and force of this water has given Venezuela an important source of energy, hydroelectric power. Guri Dam, one of the biggest hydroelectric power plants in the world. Idelca, Venezuela's power conglomerate, completed its construction in 1986, and it now produces energy equivalent to an annual consumption of 85 million barrels of oil. Its turbine generators supply Caracas, a city of more than 3 million, with 90% of its electrical power. The reservoir of the Guri Dam, covering 1,700 square miles, is the ultimate destination of the water and sediment from the tepuis. As it was filled, vast areas of forest were drowned, displacing many animals. Islands of trees remain on patches of higher ground, supplying food and shelter for their remaining inhabitants. But these islands are too small to support many animals for long. Most, like these howler monkeys, will soon have to swim to new forest. The loss of this forest was part of the trade-off for a relatively clean source of power. 70% of Venezuela's electricity already comes from hydroelectric power, and the Guri plant is not yet working at full capacity. But destruction of the rainforest has an ironic cost. These forests are the very source of the constant rains that power the dam. The tepuis serve to concentrate the rainfall into the many streams which feed the vast reservoir. Lowland tapirs swim through the still waters, feeding on aquatic plants. They're jungle cousins to their closest living relatives, the horse and the rhinoceros. Collared peccaries grazing by the water's edge roam in gregarious groups of a dozen or more. Dense foliage provides protective shelter for the shy and reclusive, and a fitting backdrop for the more flamboyant. The toucan. These birds prefer the high treetops and use their enormous bills to reach berries and seeds on the outer branches. Brilliant macaws and parrots fill the forest with sound and color, in sharp contrast to the silent world of the tepuis. The capuchin monkeys, alert and inquisitive, are the first to sense danger. The rainforest is burning, and like the flood, it's not an accident. The fires have been set deliberately to clear the forest. Large areas of the Grand Sabana are being stripped of their trees to make way for agriculture. These old, weathered soils are extremely low in nutrients, and the ash from burned trees produces enough added fertility to allow a few years of meager farming. What was once a carpet of deep green jungle is becoming a mosaic of forest and grassland. The burning has been going on for hundreds of years. The Pomona Indians have used fire to clear the land since they came to the Grand Sabana some 500 years ago. Their origins are not known for certain, but they are not forest people. They rely on farming. Years ago, their numbers were small and their fires scattered, but their growing population has increased the need for land. They set fire to the grass in an attempt to revitalize a pasture. The burning, however, does not go unchecked. Idelka has established 2 full-time firefighting companies to combat the flames with modern technology. Controlling the fires is essential in protecting their enormous investment in the Guri Dam. If the forest is destroyed, erosion from exposed soil will increase the sediment content in the Karani River, sediments that would threaten the lifespan of the turbines at the plant. The helicopter creates a wind to turn the fire back on itself. The loss of the rainforest threatens to alter the amount of rainfall on the high plateaus. Indirectly, the fires here in the Grand Sabana could destroy the fragile ecosystems of the tepuis. The effects of the fire are being studied by soil ecologist Dr. Horst Folster.
In this fire area of 1940, the forest was destroyed completely and a regrowth started. In these 50 years, it has not reached more height than we see here, that is 8 meters. And the young secondary trees are continuously dying, a sign of a very low vitality of the vegetation, very low growth, and an indicator also of the irreversible breakdown of an original forest vegetation.
The power company tries to discourage the burning, but the Indians' traditions are very strong. The staple crops are bananas and yucca root, a thick tuber which is pulped and pressed to remove the poisonous yari juice, and then later baked into loaves and other products. It's meager fare, but it's all the land will produce.
The savanna is burned regularly, every year or every second year, and with each burning, there's a loss of nutrients. The nutrients go up in the air or they are washed down. So what results in the soil is a very low quantity of nutrients. The vegetation is a result of this extremely low fertility of the soil. The grasses are extremely poor, have a very low digestibility, so the carrying capacity for wildlife or cattle is extremely low. One can say that practically this savanna grassland is without wildlife or economic use.
It may look like ideal grazing country, but the cattle can only eat tender, new growth. The food value in the grass is so poor that each cow needs more than 20 acres to sustain it. Agriculture is undermining the critical equilibrium between the forest and the soil. The crops are failing, and the forest may never regenerate. One of the very few creatures that can live in the infertile grasslands is the termite. Colonies dig hole after hole deep into the earth. But soon they too exhaust the nutrients in the soil. The colony moves on, leaving the plain dotted with defunct mounds. The forests of the Grand Sabana are shrinking, and a desert of sterile grassland is taking their place. But even more devastating than the spread of grassland is gold fever and the mining scars that gash the land. High-pressure hoses scour the sediments, causing unprecedented erosion. Mercury is used to separate the gold from the sediment. Inevitably, the tainted sludge finds its way into the streams. As mining drains vast amounts of water from the rivers, the banks are left high and dry. Fish 3 feet long were once pulled from this river. Now this is a typical day's catch. The miners come into the towns that spring up around a strike to trade their gold for cash. It may be their only source of income, but it comes at a great price. Pollution from mining sludge and increased erosion threaten the valuable water supply of the region. Idelka has entered the battle to preserve the water and protect the forest, the source of the precious rains. United by the water they share, the forest and the tepuis create a regional system of climate and hydrology. In order to learn how to manage these ecosystems to maintain the water resources, the power company is funding the research Dr. Huber and the others are conducting on the plateaus.
The phase of exploration that we started in '83 should also signify a step forward in research on tepuis. This implies that we do not so much collecting, either zoological or botanical or geological. We are more interested in studying the ecosystems, the tepui ecosystems as a whole, how they work, why are they there, what is their role in the regional or supra-regional management plans.
One of the least explored and most beautiful of the tepuis is Chimanta. It's also one of the largest, covering 150 square miles. The mists envelop Chimanta's unique assemblage of life. The golden-throated hummingbird, endemic to Chimanta. It fluffs its feathers to keep warm in the early morning sun. Indulging in a breakfast of nectar will serve to pollinate the plant. Flying insects are less common in these high altitudes than in the forests below. Their role as pollinators is all the more critical to the plant life here. In the mists, a spider's web catches more dew than prey. But even a drop of water is a starting place for life. The large Chimantea plant closely resembles the form of the Rosetta tree in the high Andes, a similarity which may point to convergent evolutionary patterns in the different mountains. Dr. Glinda Medina, ornithologist, sets a mist net to ensnare birds without harming them.
To me, to study birds in the tepuis is only an instrument to understand how the whole ecosystem works. And in a way, having an ornithologist in a group that is formed with geologists, other zoologists, and botanists, each one is contributing to understanding how this ecosystem works and how to manage the ecosystem to preserve it.
Her net has entangled a deglassa, one of the highly specialized birds of the tepuis. A nectar feeder, it's called the great flower piercer because it uses the hook on its beak to pierce the base of the flower. Until the deglassa developed this strategy, only a hummingbird could drink nectar from a flower like this. Dr. Huber carefully prepares a specimen of Chimantea mirabilis for later study. At the National Herbarium in Caracas, Dr. Julian Steiermark catalogs and analyzes the samples. Steiermark has cataloged more types of plants than anyone else in history. At last count, more than 132,000 specimens. He made his first trip to the tepuis during World War II, looking for quinine to treat soldiers suffering from malaria. He discovered instead an untouched wealth of plants on the high plateaus, including the genus Chimantea and hundreds of new species. There will be more discoveries from the tepuis for years to come. New research just being proposed will examine the genetic makeup of tepui plants and animals. Learning how life forms here are related will help scientists unravel the history of their isolation. And some of them are living fossils that will connect this continent to other continents and the great movements of the Earth. These strange, remote summits are among those rare places that still may be essentially as they were when they were formed. They hold many clues to the great scheme of evolution. Already we have learned that isolation is never quite complete. The tepuis are vitally connected to the world around them. Never again can they be called the lost world.